Hi, I'm Dr. Orin Девинski from the NYU Epilepsy Center. Marijuana, or cannabis, is a plant that has been cultivated by humans for 10,000 years, and its medicinal uses probably date back 5,000 years in China, India, and other places. Despite having been used to treat epilepsy for centuries, we unfortunately know relatively little at this time from randomized controlled trials about cannabis in epilepsy. Hopefully that's changing very rapidly. What we know about cannabis is that the two most prevalent compounds in the plant that are related to its medicinal value are tetrahydrocannabidiol, or THC, which is the major psychoactive ingredient in the plant, and cannabidiol, or CBD, which is the major non-psychoactive ingredient in the plant. So if we look at those two compounds, it's worth knowing a little bit about the biology of them. THC, which is the psychoactive substance that makes people high when they consume marijuana, binds to receptors that exist within the brain, primarily the CB1 receptor, or cannabidiol 1, or THC, endogenous cannabidiol receptor 1. The CB1 receptor is activated by THC and produces the biological effects. CBD, the major non-psychoactive ingredient, acts completely independently of this CB1 receptor mechanism. We don't today know exactly how CBD exerts its biological effects, which include, in animal models, very potent anticonvulsant or anti-seizure effects in numerous species and in numerous different models of epilepsy. And interestingly, in none of the animal models that have been looked at to date has CBD been actively causing seizures, and in the majority of them, it is quite effective as an anti-seizure agent. By contrast, THC, it is also an important and potential anti-epileptic drug based on our animal experience, because in most animal studies, THC also exerts anti-seizure properties. However, in about 10% of the animal models, THC can actually lead to more seizure activity or more seizure severity. So it is something to keep in mind that THC and CBD are really quite different, both in how they act in the brain and potentially how they affect different types of epilepsies. We still don't have really good clinical scientific data from humans, but we have quite good data in animals.